Recording. So I start to explain the AlgaeToximeter software. For the moment, the system is running, and you see several parts of the screen with different functions. In the center, you have the graphs where you can display the data. There are, for different parameters, you can open different windows. For the moment, you see two different windows. One is for the fermenter concentration of the algae culture. One is for the inhibition in this case. All graphs can show different parameters. If you click one time in a graph, it will jump to the next set of parameters. Here, it's now jumping to the temperatures, as you can see. Double click. So, oops. At the end, oops, you can move through all these parameters, which you can directly address. I say fermenter, you get the fermenter if you use a pop-up menu for selecting it, or you can just click one time in a graph to get to the next parameters. It's a cycle of 8 parameter sets. So that are the parameter, the measured data over time in the graphs here. The arrangement of the graph can be altered. There may be more graphs. I add now one graph with new window. You see there's a new graph. I say tile windows, arrange it. So now I have 3 different graphs. It's not useful always to juggle around with the graphs. So what BBE did is that there were 3 different sets of graphs, which are called macro for special interest here of the fermenter and the inhibition. That are the main parameters you want to look at. There's a second set. Okay, this is only the inhibition, because inhibition is the main target parameter for AlgaeToximeter, because this contains the information of the toxicity. Here you see a third set of graphs. Now there are 4. You see again the inhibition, the fermenter concentration, the concentration of the algae from outside. At BBE, for the moment, it's in a test run, and it's working with tap water, so there are no algae from the water outside. But if you take up river water or lake water, there will be a curve with the concentration of the algae of the sample, and also the transmission of the sample will vary over time. It's not like here, where tap water is always 100%. Okay, that are the graphs you can open, and you see the change of the values over time. On the right side, you have the process state and the alarm state of the instrument while it's currently running. Here you see on the bottom, you see there's a process. In this case, now water and algae is measured with, and you see the measurement of water and algae. Now it's measuring transmission, then it's emptying the sensor now. So you see the progress of the measurement, and this blue bar will fill over time until one measurement cycle is finished. This is in normal configuration. It takes 30 minutes until the measurement cycle is finished, but there you can see the progress. Here you see also some parameters of the process. The most important for the measurement, or not the most important, but it's important to know that the algae were in a good state. The current concentration in the culture is given here. The current concentration is 3,749, and the required concentration would be 4,500. So it is below the concentration we want. And what you can also see here, this green bar here at the left side, and the number here, 6.67%, is the amount of nutrients which are given into the fermenter. 6.67% means the pump which is adding nutrient solution into the culture is working for 6.6% of the time, and that is the green part of this bar here. If this fine line is reaching the green bar, you would see at the instrument the pump is running to put in the nutrients into the fermenter. The fermenter culture here is set to 25 degrees Celsius. 25 degrees Celsius is a good temperature for culturing algae, but it's can be also 20 or something like this. Between 20 and 25 is a normal setting. On the bottom, you see it's 1.6% working with heating. In this case, you see now there's a small red bar. That means it has to heat up the culture, and if it's blue, it's cooling the culture to bring it to the 25 degrees Celsius. So these are the main control of the process. You see the process which is running. It's still measuring the algae of the process of water algae. Okay, and the other thing is the alarms. Alarms are two kinds of alarms. One is because the toxicity of the sample water which is measured increases the inhibition, and if it exceeds a certain limit, it will be not okay. It will give an alarm, and also the traffic light then will be not green. It will be red and say, oh, it's alarm. This is the main function of the AlgaeToximeter, to say at a certain point the inhibition is not okay. There is a big difference between the reference water and the sample water, so it triggers alarm. And this will be this is a value which is evaluated. If the limit is exceeded, it will be a statement that the alarm is triggered because the limit is exceeded, and the traffic light will turn, the circle will turn red and say alarm. Additionally, there may be a third state, a gray state, because sometimes it's not able to detect alarm, and then this traffic light is gray, saying I'm not able. Here you see other parameters: fermenter concentration, firm conc, fermenter temperature, firm temp. They are okay, but if the concentration is too low or the fermenter temperature is too high, the system will complain, and then you have what we call hardware alarm. You have or process alarm. You have a problem with the algae culture because it's too hot or the concentration is too low. And this alarm says or triggers that the traffic light is gray because you will be not able to detect the toxicity of the sample water because your algae culture is not in a good state. There are some other possibilities for a process alarm. If I would not explain it fully, but also these alarms may turn this traffic light gray. If they are triggered, it's also meaning that something is wrong with the process which is going on. Here on the bottom, you see also poison. Poison is a measurement which is regularly triggered, which replaces the normal tox measurements. It's measuring the sensitivity of the instrument. And this is normally used regularly, let's say, every 12 hours or so. And the reaction to poison must be also okay. For the moment, it's inactive because the poison measurement is not taking place now. So this is the process you see, and this is a display which you only get if you use this software at the instrument. I say this because you can use the software also on your desktop computer, but then you have no hardware and you have also no process which is ongoing. Here you see on the bottom, you see also the system is measuring, and there you see, for example, the serial number of the chlorophyll sensor which is built in. And if I move on the screen on the result graphs, you see the result, which is just at the time where the cursor is standing. You see at the left lower corner a timestamp, and beside of it you see the value I have under the cursor now. So it's 100% transmission, and also my cursor is at 99.6. Or if I go into the fermenter concentration, you see there must be 4,700, something like this. Okay, on the top you have a menu bar and you have a toolbar. The toolbar I already used. The toolbar is for navigating in the data, for zoom in, zoom out, and for the arrangement of the windows. You see here, for example, 6 hours, 2 days, 7 days, and if I say 6 hours, oops, you see only very few data are displayed, but from the left to the right, there are 6 hours time span. If I say 2 days, you see much more data. It's surprisingly 2 days now in the display. So this is for the time span you see. This is also can be altered to zoom out or zoom in. I make zoom out, and you see, oh, it's a little bit longer time. It's increasing 25% of the time, and that's decreasing it. And zoom in is also possible if you want to see more details of the data. If I say, oh, this is 100%, it's transmission. I go back to transmission sample. It's possible to open a rectangle, and this rectangle, you see these buttons here now turned to a real black and blue, or mostly black. And I can say zoom in for the, in this case, the y-axis, and here you see 90, 100, 110%, and the scaling of the left side changed not from 0 to 100 something. Now it's only 80 to 120. So, and you see my rectangle is away and I cannot zoom in or out because the rectangle is not there. Okay, I want to turn it back. This is, you see auto scale Y, and this is the normal scaling now back. So with this, you can zoom in, zoom out, the Y and the x-axis, the time axis, and with this it's automatic scale of the y-axis to come back to what is the normal display here. Okay, here you see a C. The C is comment. If you do something or something is strange at the machine, you can also tag a comment, and with a right mouse button or long press on the touch screen of the instrument, you can put a comment. In this case, I say, okay, Florian was here. Now I test mode, and it will be tagged to a certain timestamp. You can also edit it and say, oh, test of toxin started. And this will be kept in the database forever, as long as you don't delete it, but it's fixed to a certain timestamp that you have commented something which occurred, which you surveyed, or when you proceeded with a test, or you said, oh, there was a tube bent, and that's because something was strange. You can comment it, and it will be put into the data. Wait a second. We just finished one measuring cycle, and you see here in the process state, now we measure sample and algae, and it's still waiting for some time, but it's a new part of the process. That's also why the graphs changed and put in a new data set, and it's fixing the graphs to also display the new data set. Okay, this was the command. This I already showed. New windows, close all windows but one. I show it. Oh, I closed all windows but one. You remember I use macros. With this macro, I get 4 different graphs, and I got back to it. Okay, that is the toolbar more or less. You for navigate in the data, left, right, one time series, or go to the last data that are the newest data at the right side. Zoom in, zoom out, zoom the y-axis, zoom the time axis, automatic scaling, comment, window arrangement. Okay, I forgot to, this is the caption. The caption is for if you want to resize the windows, and to see more, you hide the captions, and then you have more space for the graphs. So now it's getting into the control of the instrument. The instrument is running now, and this is, you see here, I started now with a measurement menu. The menu here, you see, start is gray because we are running, and you have the capability to stop it or to quick stop it. What is the difference? The stop is running a series of processes to clean the system. It's stopping everything, but it's also moving out all the algae which are currently used in the process to leave a system more or less clean. The quick stop immediately stops the pumps, and that is if you do maintenance and want to do some cleaning or so, you will make maybe quick stop. Quick stop is so far used if you are in a hurry and wants to do something and you know it's not important that the system is put in a controlled clean state. So quick stop is within seconds it's finished, and stop takes some minutes until in every place there is clean water put. So this is most important for operation. Sometimes or pre-fill is after maintenance. You can say, oh, I have empty tubes where you have no water. So pre-fill says triggers a process which is preparing the system for the operation after it was maintained, or after, especially after it was maintained, because in some tubes is still no water and so on. Comment, I already said it here, but auto comment is if you start the system, you may put a comment there, and this comment will be fixed to the first data point you produce, but this first data point may take nearly 1 hour until it's produced. So you can put the comment and go home after maintenance, and it will be fixed to the first data point set, which is measured. Okay. Options. Normally you don't touch the options, but there are options which you can activate or deactivate, which are controlling, for example, whether you regulate the fermenter concentration, whether you regulate the temperature of the culture, in the case of the measurement is working, but also in the case of the measurement is stopped. Sometimes, because of some reasons, you may stop the instrument and without measurement, and then you have also to decide what happens to the instrument. And yes. Okay, the view is corresponding to many of the icons you see here. You can move to the first data set, to the last data set, or one page left or right, or you can choose a time span of 1 to 6 days, or 6 hours, or 1 week. And you can scale and rescale, zoom in. Okay. And with this, you can show the comments or hide the comments. Okay, that is for the view. The windows we also have here on the toolbars here. The window. There are possibilities to create new windows, to arrange them. Okay. What we showed for the moment are all graphs windows. There are also there's also a message window. The message window is talking or only showing something about very basic process steps. You see, it's telling you when somebody started the measurement, or it's also recording when somebody said stop the measurement or make a quick stop of the measurement. And sometimes you see this is a warning and telling you that something is strange. I activate the caption, I close this window, and this set of window I want to show you, there's also a numerical display in the form of a table. This table contains all the data which are seen in the graphic display, and you can move it. It has a lot of different columns. Not all these values are displayed on the screen, but you can see, for example, here I will show something else. Only to show to you, here you see on top transmission of the sample, and you have different wavelengths of the LEDs in the sensor, and you can see for every value, every different LED, you can see the transmission values of the sample, but also for the reference water, you can also see transmission values, water and algae. This transmission values will not be, there's no graphic display for it because normally there's no use of it, but these data are present, and you can look for it if you want. There's a lot of data, you normally don't need it, but it is there in the database, and this is a window where you can see numerical data. Oops. Okay, that's more or less what I can tell you about the windows. Now, this is for the instrument. Now we are getting to the most important, the control of the instrument. One is the fermenter regulation. Fermenter is the chlorophyll or the algae culture is controlled here. You see here what I already showed at the right side at the process state. Here you set, for example, the required concentration of the algae culture, and some of these parameters are there, but I expect you never touch it. That is the control of the regulation of the temperature or the regulation of the algae concentration. The expectation is this you hopefully never touch. And what is also important for controlling the algae culture is you have to exactly know the volume the pumps are delivering. There are 3 pumps. One is the nutrient pump, and here you see there is a metered volume of nutrient solution. The sample pump, there you see algae volume, also milliliters per hour, and the sample volume is much larger. That is the main pump, which is pumping any water type through the system, the reference water and the sample water, in the case also the toxin, the reference toxin solution. And all these 3 values are metered and must be more or less metered exactly, but there's later I explain it, a assistant which is helping to fix these values. or to meter these values. That I forget, the measuring times. This is the menu, the dialog for the parameters for the fluorescence measurement. This is configured by BBE. You see, oh, there are something like brightness measurement. There are adaptation times for what we call F0. That is the measurement with low light conditions, and there's a measurement with maximum light condition. This is a parameter set which is delivered by BBE, and expectation is it will not be touched by you. It is controlling the chlorophyll sensor, which is measuring the concentration, but also even the activity of the algae, how well are the algae feeling, not really, how well is the state of the algae. So now I come to a parameter set measuring times. Now I come to measuring procedure. Here you see a complex dialog with several tabs. You see general, the measurement interval now is set to 30 minutes. 30 minutes is the overall time of all the measurements which are triggered one after another to produce one data set of toxicity. I already said, okay, here one is the poison measurement frequency. In this case, you see we take every 30 minutes a measurement. So we take 2 per hour, and 49 is a little bit more than 1 day would be the measurement of the poison, the reference poison, and the cleaning count. That is in the chlorophyll sensor. You have a cleaning device which is moving down and up, and this is taking place after 10 measurement cycles. So this would be every 5 hours. It's cleaning the chlorophyll sensor inside. You see here a list of processes which are displayed here with a number and seconds. The test button is gray because we are on the measurement, working on the measurement. Wait a second, I cancel. I trigger now a quick stop. And you see here, it's jumping to idle and the progress bar is gone. Now I'm able to change the parameters. It's only in the stopped and the idle mode. And now you see in the measuring procedure, pump times, you see a test button, which is black, so you can trigger the process. Only to show to you, if I say test, you get a test window and the running time and the remaining time, and you can stop and apply or abort. But the main thing is you see at the instrument this time how the pumping is ongoing. Normally you don't have to touch it, you have to leave it, but in case there are problems, you can see, for example, you see also test empty sensor. And with this, you will see all the sensor will be emptied by the water with pressurized air. And you can see whether it's empty after this 12 seconds or not. And if the 12 seconds are not long enough, you can fix it and say, okay, I want to have 14 seconds, or you can shorten it. So there are a lot of tests possible to see how the pumps are performing for a certain process. There's even more. The pump times, the loop control inside the instrument, there are 2 loops. The loops are a certain a fixed pipe which has a certain volume, and these loops were used to store the algae which are taken from the culture, injected into a water. They are stored in the loops and left there for a certain time that they can react with the possible toxins which are contained in the water. And with this process, you can control the loading and unloading process of the loops. And because there are 2, so you also have 2 test buttons. Normally you don't have to touch, but maybe on a bad day you have to check whether one of the loops is blocked by dirt or something like this. So you can test each individual loop. Okay, the other things I don't explain here fully. You have also the possibility, after you triggered here some of the pumping processes, if you say fill sensor with a sample, and you put it like this, you fill the sensor with sample. You can, at the end of this process, you know, oh, I have water with sample. You can also measure it immediately with this, but it's only for test purposes. It's not for the permanent measurement which you want to take. Now the sensor is filled with sample, and you can trigger a single F measurement, and you say measure. You see here it's measuring the sensor contents, and it will take half a minute or so until we are getting results. Expectation is it's near to 0. Here this should be near to 0, and yeah, we wait. Transmission, now it's calculating, and you see it's producing some values, and there's a small amount of green algae inside the water we pumped through the system, but it's a part of dirtiness that some of the algae which we use for the whole process are still somewhere in the tubes, but these green algae normally come from the culture here in a small amount. Okay, that's to show you. You have also the possibility to measure it. I say empty sensor to pump in air into the sensor again. This is for controlling the whole pumping process. The parameters. That was measuring procedure. Fit, I only show short time for you. All the chlorophyll sensors here have a complex set of parameters which are storing especially zero line of the sensors, and we have also the possibility to detect different algae types, algae classes in the water from the sample. So here is the parameter set for the sensor, but you will not have to touch it. It's possible, but expectation is you don't have to touch it. This is a calibration, the result of a calibration made in factory. This is the second part of the parameter set. You see there are even more parameters you also don't have to touch, but it's visible, and maybe you will be asked for it. This is the parameter set alarm. The alarm is the most important parameter set for triggering the alarm at the traffic light. Sorry. This is the parameter set which is controlling the triggering of the alarm because limits were exceeded. And here there are two possibilities of alarm. The short and the long range limit, and the short range limit is 5% if you have some values, 2 values out of 3 values which are exceeding the limit of 5%, which is strong. Then you get an alarm on the long range limit is more sensitive. Here you see there's a value of 2%. If you have 5 points out of 6 which are above 2%, you trigger alarm. And if you see this graph here, inhibition, it's in a normal run with clean water. You see the noise is around or in a range of plus minus 1% of the inhibition, and if it's permanently exceeding 2%, you already get alarm. But it's somehow dependent on how you operate the instrument, how are the changes of the sample water over time with the load of external algae. Maybe these values have to be adjusted to your situation or your site, your water. Okay. Alarm. I already talked about the process alarms, and you see here, for example, there's a process alarm when the fermenter concentration is getting below 1000, or if the temperature of the fermenter is above 35. And if you get very strange readings of the inhibition, we say this is not possible, that exceeding minus 10 or is below minus 10 or above 50%. You get a information that you get a process alarm because we don't believe that you exceed this range. And here is a setting for the reference poison. You see 5 to 45, it's a wide range, but it has to react to poison. The algae have to be impressed by the poison, otherwise you get also a warning or alarm. Alarm and warning, there's a difference between it. The alarm here, if you get the algae in the culture cooked because it's above 35 degrees Celsius, the system may stop. That's why there's alarm. In the other ways, it's only maybe a strange data point, but the system will proceed. Process alarms here, always on display. Okay, these are some parameters, analog output. It's still possible that you transmit the data not digitally. You have a 4 to 20 milliampere loop, and these outputs can be configured. What is the value for 4 milliamps? What is the value for 20 milliamps? And you can put here, you see there's a parameter inhibition put on it from -2 to 8, or the fermenter concentration. Where is it? The total chlorophyll concentration in the fermenter is from 0 to 3000. That would be not enough to show what you see in the graph, because required concentration is set to 4,500. You will put maybe 6,000 for the spreading of the analog output if you reach the chlorophyll concentration, as an example. And you would say, this is old-fashioned, very stable 4 to 20 milliampere output loops. There are 2 channels for the output. There is also a connector to the outside for the relay output. There are 2 relays, and one is relay. You get a limit alarm here. The traffic light is turning red, or you get a process alarm. Something here, you get red, that you get a process alarm, and the traffic light then will be gray. This can be configured here, and there would be also testing possibility. This would be switch on the relay, and this is a switch off the relay, that you have to use at the beginning if you install the instrument at the start, and your electrician is connecting the instrument and want to see get the signal. Then it's easy to switch on and off, and he will say, okay, I see it or not. Okay, output. First, I show you sensor identity. The sensor identity inside the instrument is what we call a chlorophyll sensor. This is the big tube at the right side, which is measuring the fluorescence. And you see the serial number, software version, and the factory calibration date. This will not change over time, but if you would send for at a certain time the sensor to us, the sensor will be calibrated, and you will get a new factory calibration date then there. And from time to time, it's necessary, and we ask for it when was the last inspection calibration. So the sensor knows all the parameters necessary to control the sensor. The sensor has a computer. So we see this here, and after such a calibration, or if you put in a new sensor, it normally automatically detects the serial number of the sensor, and if the serial is changing, it's reading the parameters of the new sensor. But if you have a differently calibrated sensor, normally it's reading the data from the sensor, but you can also manually trigger the reading of the calibration. Okay, there are some other test facilities in here, only short time to show. This is a possibility to check every valve, every pump. You see air pump, you can switch it on or off, but with this you say, okay, the pump is working or not, or the sample pump is working or not. You can also switch on the light, but this is for if something strange is going on. You normally don't need it, but it's their testing facilities of every electrical unit in the instrument. With the test dose pump, you can test the dose pump, but also you can add a certain volume to the fermenter. If you see, it's not fully filled. If you put in new algae, you can also say, I want to fill in 200 milliliters, and then you start it, and it will taking you, oh, it's filling the fermenter, but you see it's taking a long time now to fill in this 200 milliliters. I told him, but this is no surprise. I abort 200 milliliters, only to show it to you again. In the parameters of the fermenter regulation, you see the nutrient volume as the rate of the nutrient delivery of the pump is only 960 milliliters an hour. So you can imagine that 200 milliliters are somehow above 10 minutes because the pump is only working very slowly or a small amount. Test cleaning is inside the sensor. I said is a cleaning piston which is moving down and up, and this can be triggered. And if you're in front of the instrument, you would hear a certain sound, and with this you hear that the cleaning is working, and you see after some time it's finished and it's measuring the time. I have to move it up again, and it will be maybe also 17 seconds until it's moved upwards. Why we have a test facility for this? If you have a very long time no maintenance, maybe the O-rings which are used for the cleaning may be very rough, and maybe at a bad time it really got stuck, or it takes a too long time to move. So this is a possibility to test the cleaning device. That is not longer valid. Okay. From this menu, I only talk about the pumps. We had already heard that the volume the pumps are delivering is important, and it has to be metered. And this is how to say an assistant to help you to meter the volume which is delivered by the pumps. The volume may change over time if you put in a different type of tube, or if the tubes are getting too old. You may exchange it, but maybe you check also the calibration. And there are different types of pumps: the sample pump, the algae pump, the dose pump. And you can, at the sample pump, you are even capable to measure the sample pump volume with sample or with reference water. And this assists us. You have to make a choice of the pump, and then you have to start to be sure that you have no air in the system. You will start it, then it's working until you stop it. Okay, now everything would be with water, and you would have to take up at a certain point a tube which is coming out the pump, where you pump your volume, and then you would start the calibration, which is here set to 60 seconds. The tube you cut or you take off, you put in a suitable graduated cylinder where you can meter the volume of water, and then you start the calibration. And now this will run for normally 60 seconds. So if you have a pump which may deliver, let's say, 10 milliliters per minute, you would choose a cylinder which is taking up 10 or better, maybe 20. It's better. if you use a 10 milliliter cylinder, you may stop at a certain point and say, oh, exactly 10 milliliters are delivered. So you say stop. And so this 10 milliliters were only delivered in 33 seconds. And in the next process, you see for the, we measured the sample pump. The sample pump, the metered, the former metered volume was 10.8 liters, 10,800 milliliters per hour. And with a pump time 33 seconds, the expected volume would be 100 milliliter, more or less. And the result of the new calibration would be 100. And you see on the bottom, the new value is calculated. And if what I don't do now is if you say apply, it is copied into the parameters of the fermenter regulation, and it's put down there and used for all future calculation. This is possible for the different types of the pumps, and sometimes you have to check it, but it's depending on the quality of the tubes you use, or maybe you do it, and if it's very strange other value, you have to think about that maybe something is wrong. Something is wrong, maybe if you have a blockage in the tube system, your pump calibration will fail because you don't have 100 milliliters in one or 1,000 milliliter or whatever. If you have only 500 or 50 or whatever, and it's a strange different value, that means something in your hydraulic in the tube system had changed. Okay. All these other things I leave out. It's not really necessary. Sometimes we ask you which version of the software do you use. This you get by help, so it is not a help system, but on the instrument there should be also the manual for the AlgaeToximeter. Wait a second. I have to check, but the manual should be there. Okay, that is more or less the okay, I forgot the first. Open, close, and you see here different databases which you can open. It is possible to export the whole database. For the time range you see here, the time range is exactly what you see in the graphs. You can change it also to other dates and times. When you export it, you can use it, the exported database on your computer if you use this software, or you can send it to us if you have a problem. All the parameters, all the recorded data of this time span are put into the database, so we know all the messages, all the recorded problems, everything which is used for generating these data points, we will see in the database. So if you have a problem, we want to have an exported file. I say test in this case. Select type as ATOX database and save it, and this you can send to us, or you can use it on your desktop computer to work revise the data. This can be opened. Test demonstration. This would be the database with the data you exported to somewhere. With this, it's possible for you to revise the data, and for us, if you have a trouble, we can see a lot what's ongoing. We can produce these graphs, but we also see every parameter of the instrument, from the pump volumes, from the sensor settings, the pump times. Everything is contained because every data point is belonging, or to every data point is belonging a data set of the parameters which are used. So this is the AtoX software at the instrument. This is the main function of it, and recommend to use it on your desktop to get familiar with a lot of the functions. Thank you.
Thank you very much, Florian. I've got some questions. May I ask some questions?
Yeah, please.
First about this cleaning of the chlorophyll sensor. Is it cleaning with a piston mechanically, or it is cleaned by air pressure, or both of them?
In the normal process, all the measurements are finished by I empty the sensor. Empty sensor means it's pressing air into the sensor, so the sensor is more or less empty with some remains of dirt. And then the system is pumping in times water and emptying it again. So it's rinsing the sensor 2 times with water, and 2 times it's 3 times it's pressing it free with air. It's a
how it's pressing? There is a compressor, air compressor, to pushing the air inside.
In the AtoX is a air pump. The air pump is used normally to produce the bubbles in the fermenter, but there's a Y piece and a valve. One of the front valves is for opening it to put into the output of the sensor, put in there the air, and this is pressing back the water into the drain. This is a major cleaning process which is taking place several times during a measurement cycle, and it would ensure most of the cleanliness because it's emptying and rinsing the sensor, and at the end still the mechanical cleaning with a piston is activated. Here you see in the parameter set every 10th cycle. That means every 5 hours.
I understand. Okay. The other question about the reference poison measurement, is it an option or it is already in every unit?
It's not an option. It's normally built in. You have a valve at the front of the instrument on the lower left side, and one is switching to reference water, one is switching to reference poison, and one is switching to the sample.
How we can activate this or deactivate? Is it possible to deactivate it or activate it? Which menu we should go?
It's possible to deactivate it if you say the reference poison should be measured 0. So it will not be used.
Which menu? Which menu? Could you please show us? Measuring pressure. Yeah. If you make it 0, it means that there will be no poison, reference poison. Okay, clear. Now we should.
Okay, one explanation I forgot. You're still recording, yes?
Yes.
In the inhibition graph here, I zoom in a little bit. You see a lot of data points, and you see an average line which is a little bit jumpy, but you see some very small red dot points.
Yes.
This, there.
Yes.
That are the reference Poisson measurement. BBE was a little bit lazy because they did not use really reference Poisson. They only put reference water. That's I'm not 100% happy with it, but you see the reference Poisson, you have some red dots and connecting lines.
I see.
You see also here on the graph, you have the inhibition itself, you have the fit or the average line,
Yes.
and you have the red point if you measure Poisson. This will not show up if your measurement cycle is set to 0. If you don't measure the Poisson, then you will not see this explanation. If you have one of these red dots, if you we now switched it off, but you still have the reference Poisson measurement in the display, so this will show up as long you have them.
I see.
Okay, but that you can deactivate if you don't want it, and some customers don't use it, but the valve and the input is there, but you are not urged to use it. I put again 49 because I like more if really regularly this is measured.
And the other question I had was about the reference water. So, how much reference water we need, and which quality it should have. Is there any recommendation? Because most of the people are asking about this.
Yeah, reference water in some areas of the world, it's worth a discussion. At BBE, we use tap water because we don't care for it. Tap water is not always suitable. Tap water may be chlorinated, and if it's heavily chlorinated, it may be toxic itself because the chlorination also kills algae.
Yeah, of course.
So the question is whether you have chlorinated water, and I think in warmer regions and more tropical regions, you have increasingly the chlorination. If it's at a low level, I think you can work with it, but it's really there's a big range which is possible. So it has to be checked, let's say.
What about the distilled water or deionized water? Also, it will kill the algae, yeah?
But not so fast. It's not perfect. You put them into osmotic stress, but I know places which were operating AlgaeToximeter and they use millicube water. So the deionized water may work, but the problem with the reference water is the reference water is also used for cleaning, rinsing, and separation of the different waters. And as a rule, I would say you need at least 50 liters a day. So it's not useful to use barrels.
Of course.
Sometimes the people try it if they operate in a laboratory, and then they forget to refill them. And I only can say that the consumption of 50 liters a day, more or less, is a figure you have to think about. It's depending on the pump times. If you have longer pump times for filling the loops to reduce the noise, it means also you have more water consumption.
Thank you very much. The other question is about, actually two questions remains. The first one is about in the manual it is mentioned that we can also clean with KOH, the potassium, some sort of solution. We can use it. What is the application? Why we need to clean it? Because you mentioned that we clean it with reference water, but maybe in some cases we need it to use this.
Okay.
How is it is essential? So how we can understand visually we should check it.
Yeah.
We need to do it.
The sensor is cleaned automatically by rinsing and later by the piston, which is moving up and down, down and up, but in the tubes there is a forming of biofilms, and especially the loops where the water is stored for a certain time. Normally during a measuring cycle of 30 minutes in the loop, every type of water we measure is stored for 20 minutes. And during this 20 minutes, there's sedimentation, but there's also the algae will also try to settle down, and at the end they may glue to the surfaces of the loops. So everywhere in this system you have a build-up of biofilms, but it's one thing, it's depending of the algae from the culture, but mainly from the sample water outside. You have bacteria, you have algae, you may have also mineral components, so you have to clean. It is rinsed, but still by the rinsing, you get not rid of everything. The biofilms will be growing over time. So you have to do regular maintenance. We say every week you have especially to clean the loops.
Okay. Thank you very much. The last question, I put it for tomorrow, the next week that we meet each other, then I will ask you. Because I should show it in the unit, so it's not possible. Anyway, thank you very much. I appreciate. I will make it a video and I will inform you about this video. Yeah.
Okay.
Have a nice day and schönes Wochenende.
Ja auch.
Tschüss.
Tschüss.